5 tips every induction cap sealer user should know. This is Mark Plantier of Intercon Industries, and we are very pleased to bring you this informative webinar designed to help you understand key induction cap sealing concepts that will improve your success. Please note this webinar is being recorded and will be made available to all registrants as soon as it's posted online. You may ask a question at any time during the webinar by typing it into the question tool provided on your screen. Our panelists will answer the questions at the end of the webinar. If there is not time to answer all of the questions during the webinar, our panelists will follow up with you after the webinar. Topics that will be covered today include the induction sealing absolutes, pressure, heat, and time, sealing head design, how to identify a good seal, finding your operating window, automation options that can improve your productivity, and we will wrap up again with a question-answer session. As an attendee of this webinar, you'll be eligible to win a Super Sealed Junior Cap Sealer. This compact yet powerful cap sealer is ideal for short production runs and laboratory use. The winner will be notified later today. In addition to the presentation slides and webinar recording, everyone in our audience today will also receive access to Intercon's Induction Cap Sealing ebook, our new Seal Integrity Guide, which shares characteristics and remedies for containers that fail to seal, only achieve a partial or weak seal, or show signs of overheating. We'll also send you a link to download Intercon's cap sealing setup log and checklist documentation. We're fortunate today to have two extremely knowledgeable professionals in the area of induction cap sealing equipment and applications. Jeff LaGrange is Intercon's Cap Seal product manager and has worked on developing Intercon's innovative line of Super Seal induction cap sealers as part of the Intercon team for over 22 years. Owen Schmidt is one of Intercon's regional sales managers, and for the last 7 years, Owen has traveled around the country consulting with packagers on their induction sealing projects. Owen has a passion for ensuring that packagers understand the induction sealing process and maximize their productivity. With that, I'd like to turn it over to Owen to begin with the induction sealing absolutes.
All right, thanks, Mark. So with any induction sealing application, there are 3 critical factors that we'll be looking at. The first being pressure, second heat, and finally time. The first aspect would be the pressure, and this would be probably the most critical that we'll be talking about today. It is absolutely crucial that the closure is screwed onto the jar properly. That is going to ensure that we get even pressure around the entire circumference of your jar, which is essential for creating a good hermetic seal. I would say the vast majority of all induction sealing issues are related somehow to low cap application torque. So this, if you were experiencing any issues, this would be the first place to check. This next slide here just shows the general guidelines. This is a very accepted guideline for recommended cap application torques. Accepted that half the cap's diameter in inch-pounds of application torque is suitable for most applications. This will change depending on the bottle and the cap configuration and how they match up together. Some applications may require a little more, some applications may require a little less, but this is a good guideline to start with. The second variable would be the heat. The heat is created when the foil liner actually reacts with our electromagnetic field that we produce. That heat, basically, the electromagnetic field is going to vibrate your foil, really fast currents in there, and that heat is going to melt the heater, which is laminated underneath your foil. That's what actually creates the seal and bonds to your container. The final variable would be the time. The time that we are concerned with is measured in conveyor speed, feet per minute or meters per minute. Most applications or variable, most customers are going to call us and they're going to talk in terms of bottles per minute or production output. What we're concerned with is how fast that belt is actually moving, so we can essentially measure the amount of exposure time underneath the induction sealer. So these variables all interact together to create a successful induction sealing application. It's important to know that the relationship is not linear between these. So if you were to raise your induction sealing power percentage 5 percentage points, that doesn't necessarily mean that you can raise your conveyor speed 5 percentage points. If you were to need more sealing energy, there are two things you could do. You could essentially raise your sealer output or your power percentage. That would increase the heat in that equation. Or you could slow down your line speed, which would increase the time and give you that increased energy that you're looking for. Conversely, if you need less sealing energy, you would decrease the power, lowering that heat in the equation, or increase the line speed, which would lower the time. With that, I will turn it over to Jeff, and he'll talk about how to make sure you're using the proper equipment.
Thank you, Owen. Now, as we all got different kinds of caps. There are big caps, small caps, fat caps, skinny caps, snap cap. I could go on and on. I'm going to try not to, though. Each one of these is going to require, or may require, a different kind of sealing head. At Enercon, we've developed a wide range of sealing heads that will cover almost any application that you can come up with. For example, we've got a deep tunnel head on the lower left that will handle something like a Yorker cap or a syrup cap or a sports cap. We've got wide flat coils that can handle the big 120 millimeter diameter caps. We've got tunnel coils that will do up to 53 millimeters, and a universal coil that will, it's kind of a jack of all trades. It can do anything from 20 millimeters up to 120 millimeters, flat caps at least. As you may have heard, with the Super Seal Touch, we made some improvements to our universal coil. We refer to this one as our all-in-one head. We tried to remove some of the confusing aspects of lining up the all-in-one head for the proper size. This one is, the adjustments are all done with a single hand. There are positive stops for different cap sizes, and it really makes it a lot easier for your operators to set it up properly to reduce the errors that are done.
Jeff, this is Mark. Can you talk a little bit about a flat sealing head, and is it possible to seal some other types of bottles that we might normally specify a funnel for, and what's the pros and cons of doing that?
Well, that's a good question, Mark. A flat head can do up to 120 millimeters, and that is what it does best. It can seal smaller caps down to 38 millimeters. I would not recommend it for something that is smaller than that. It's just not very efficient at heating up those small liners with the way the coil is. But the standard flat coils, the all-in-one coils, the universal coils are very just that, universal. They are, like I said, the jack of all trades, and they can do anything from a 20 millimeter up to 120 millimeters. The flat coils are not very well designed for you doing sports caps and things like that, something that has an increased head space built into the cap.
Thanks, Jeff.
Thanks for pointing that out, Mark. So once you give us the information on the kind of cap you're sealing, and you know that we can get you set up with the right kind of coil for that kind of cap, then the last part of the equation really is how fast do you want to go? And that will determine what size power supply you're going to need. We've got anything from the handheld Super Seal Junior, which Mark already mentioned earlier in the presentation, up to our Super Seal Max that can go over 350 feet a minute on certain applications. And we've got everything in between. So if you let us know what kind of cap you've got and how fast you want to go, we'll make sure you've got the right piece of equipment for that application. All right, now that we know what kind of equipment there is and how to get the right kind of equipment, Owen's going to talk to you about how to determine how to get a good seal.
Thanks, Jeff. All right, so this slide here, you're looking at various stages of an induction seal, and successful or not. So the first picture is no seal. Obviously, the foil's still left in the cap. You go from no seal to partial seal, where it's partially sealed there. Then you find that good seal, and that would be a good indication. That's what it should look like, and then you can see the overheated seal. Now, those are just the characteristics. How do we measure whether or not we have a good seal? There is no ASTM guideline. There are no specific guidelines for induction seal integrity. It could be good and that can be bad. The good news is you're not doing anything wrong. The bad news is you don't really have any direction as far as how to do your testing. Each company is going to have to go and define a good seal, what they consider as a good seal, and then go out and lay out their testing method to determine whether or not they are getting good seals according to their standards. Some good seal characteristics that you're looking for visually would be good adhesion around the entire circumference, as you see in this picture here. You want minimum wrinkling of that liner. Excessive wrinkling would be a sign of overheating or overdoing that. And then no discoloration would indicate the proper output level. With foam back liners, as you see in the picture, you're looking for that foam to still be intact, and again, you want minimum wrinkling. Foam liners are real nice lots of times just because they show that overheating pretty quickly, so you can really tell whether or not you're doing things correctly. On a two-piece liner, you have a pulpboard that's left in your cap, and again, the first sign of overheating that would be discoloration of the pulpboard there. So, besides the visual indications of good seals or bad seals, there are several methods out there to do testing. There's a vacuum chambers, but both wet and dry vacuum chambers, depending on the application that you're doing. We have customers that do shipment tests, so we can seal up samples and ship them back, or they can seal them up and ship them to their customers just to make sure that the seal holds up in transit. There are vision systems out there that will look for seal integrity as well. There are systems out there that will mechanically apply pressure to the jars or the bottles as they're traveling down the line or offline, just to measure any kind of pressure differences along that line. Probably the most popular methods are on the bottom here, and as you see in the picture. Most folks are going to shake the bottles, they're going to squeeze the bottles, or they're going to stand on the bottles even. Different applications are going to be capable of handling different amounts of pressure. As you can see in this picture, that bottle is designed to withstand quite a bit of pressure, but other ones aren't going to be able to take it. So it's a matter of using those methods. The only issue with those methods is quantifying your results. Who is squeezing those bottles? Who is standing on them? Who's shaking them? And to make sure that everyone's doing it consistently is difficult to do. Here at Enercon, we use a vacuum chamber in conjunction with the customer specifications. So again, my definition of what a good seal will be doesn't necessarily mean that that is our customer's definition of a good seal. Customers have different requirements depending on their application, depending on who's opening their jars and such. So we need the customer to tell us how much pressure that particular application needs to withstand in our vacuum chamber, and then we'll test to those specifications. When should you test is also another question that we get all the time. There will be an immediate hermetic seal created through the induction sealing process, but that doesn't mean as soon as the jar comes out of your induction sealer to go ahead and remove the cap and put it through its paces. We want that seal to cool down before you go ahead and remove the cap. You're essentially removing that pressure right away when the heat seal layer is in a molten state, which it's like, I always say, it's like gluing something to the wall but not holding your hand there. It's not going to stick as well. The liner folks will tell you that the seal strength changes over the first 24 hours. In my experience, it typically gets stronger, but your true test would be 24 hours later to see what your longevity and real induction seal is going to be like. With that,
this next topic Jeff is going to cover is probably the most important piece of information you're going to get today. We've covered this in other webinars, and there's even a video online that shows this process. And our customers who adopt this have far less rejects, and they are quicker to find and troubleshoot reasons for partial or weak seals than those that do not. So if you take away one thing from this webinar, this is the important section.
Thank you, Mark. So what we like to refer to in cap sealing is that your operating window. That's a term we use to define the area that you can get a good seal. As you can see in this graphic, on one side you've got no seal, it slowly works its way up, and then you've got a good seal. If you keep going up, you're going to overheat that seal. And what you want to do is position yourself somewhere within that green section where the good seal is, and that is what we refer to as your operating window. This is going to maximize your chance for success. As you kind of see a different looking graphic there, you can see you've got the good seal section in the middle. There's the lines of transition from a good seal to a no seal or overheat. And if you put yourself in the middle of that good seal, you're going to be able to compensate for variances in cap torque, or maybe your bottles aren't going exactly down the center of the coil, or your line speed is fluctuating, or your bottle height might be changing. Bottle heights have tolerances. So if you put yourself in the middle of that good seal section or somewhere inside there, you're going to be able to compensate for those, and you should still get a good seal even if you have variances. So how do you find where that section is? Well, first thing you have to do is make sure that your cap sealer is set up properly. We recommend an 1/8 inch gap typically between the top of the cap and the bottom of the coil. On a standard coil, with a deep tunnel coil or with a sports cap or something like that, it's a little bit different. You want to line up with the foil arrows, but we want a consistent gap all the way through the sealing section. You want to make sure the bottle is controlled and going down the center of the coil as well. You want to make sure the coil is set up parallel to the conveyor. Now, that's important that it's parallel to the conveyor and not necessarily parallel to the floor, because your conveyor might not be parallel to your floor. So what we do is with every system, we ship a gap gauge, and we recommend you use that. You put a bottle in the front of the coil and a bottle at the end of the coil. Put your gap gauge in there, as you can see in the picture there that Mark is pointing to. You put your gap gauge in there, and you can adjust your coil to be parallel to your conveyor in this way, and that's probably the best way to set your coil up. Once you've got your system set up properly, you're going to need to run some tests. You're going to need to run some trials. There's really no way around this. We can't tell you how fast or how high to run your sealer. You've got to run the test with your application, because every application is a little bit different. So what we recommend is you start low. First you want to determine the low side of your sealing window. So you start low, say 40%, and you run a sample, maybe a couple samples, and you expect to seal. At 40%, you're probably going to find that you've got no seal. So then you turn it up by 5%, you have 45%, and you run another sample, and you find, oh, you're still in the no seal section. So you turn it up by another 5%, and essentially you're working your way up. Here at 50%, we've got a partial seal, so we go up another 5%. And oh, I'm sorry, go up by 1%, you've got a partial seal. We're trying to inch our way up to a complete seal all the way around. So 50%, we go up by smaller increments at this point. We get up to 51, we've still got a partial seal. We work our way up and we get into the good seal at 58%. At this point, we've determined that at 58%, that is the minimum setting where we can get a good seal. So you want to kind of write that down. You want to note that 58%. That's going to be the low end of your sealing window. The next step is to find the high end of your sealing window. So you can start at your low end, in this case 58%, and we just ran a test, so we know that that's a good seal. You're going to increase your output, say by 5%. You run a test, you're still getting a good seal at the 63%. So you increase again. Now we're at 68%, and we determine, ooh, well, we've gone a little bit too far. We're starting to see signs of overheating. Maybe the liner is starting to smell funny, or you can see scorching marks on the pulp board. So now we've gone past that. We need to back up a little bit. So you slowly start dialing it down. 68 to 67, you're still seeing a little bit of burning. Eventually you get down, you find out that at 65%, the burning is gone, you're still getting a good seal. So what this has done, it is defined our operating window, in this example, between 58% and 65%. Now that's somewhat common. Sometimes you can get a 10% window, depending on your bottle and your foil. You can get a 15% window, and you've got a lot of leeway. In this case, you've got between 58% and 65% where you can get a good seal. You determine that with this process. So now you look at this graphic and you say, okay, anywhere between 58 and 65, I can get a good seal. Where do I want to run my production? Many people will say, well, I want to go right in the middle of that because it will compensate for all those things we talked about earlier. Some people might want to run a little bit on the high end because they prefer to be a little bit overheated. That's more acceptable than have, you know, a leaker. So maybe they want to run at 62%, 63%. But generally, you want to run somewhere in the middle of that green area. In this case, the right in the center would be 61.5. So once you've done that with product A, for example, if you're running multiple products, you're going to want to record that somewhere. We've got a sheet that we can provide you. I think Mark mentioned it early on, and we'll talk about it again later. But you can write down your product, what the product is, what the bottle size is. You can keep a log of this so that next time you run this product 2 weeks from now, you don't have to go through this whole process again. You know, oh, as long as I've got it set up right, I can run at 61% and I'll get a good seal. We've also got a checklist that your operators can use, that they can go through to verify that they have properly done all the setup steps that are necessary to make sure that they have gotten themselves in the middle of their sealing window. We can provide you this checklist as well. It contains all of the things, the information about the container and the closure, what the line speed is, and it kind of gives you some documentation that if you go and need to look something up down the road, you can say, yes, we went through the process for this application, and we did the steps that we needed to do to get a good seal. So now that we've learned how to find where to set up our system, how to get a good seal, Owen's going to talk about things that you can do to integrate your system into your line.
All right, so the induction sealer, when it's set up in your line, it's probably one of the simplest machines that you're going to have on your production line as it comes out of the box. And what we'll want to do is highlight a couple features, a couple options that you can use very simply to help improve your productivity. The first and most basic of that would be the stack light, the flashing light indicator. This is a good indication, a good visual indication for your operators to make sure that the sealer is functioning properly. If this light is green, that means there's output to the sealer, to the sealing head, and you're able to run bottles underneath that sealer. If it's red for any reason, it just means go check your sealer. It could mean that somebody hasn't hit the start button. It could mean that there's a fault or a stalled bottle or something along those lines. So it's just a really good visual indication. On our new touchscreen models, the SuperSeal Touch and our new SuperSeal Max, the touchscreen itself also is color-coded depending on the running condition of that induction sealer. The second feature here is what we call the LSI or alarm. LSI stands for loss of sealing indicator, and then on the newer systems we call it the alarm level. Basically what this does is it kind of works in the same way that the stack light would, that if something were to happen to your sealer, if you lost power or if somebody didn't hit the start button, there's the contact on the back of the unit that you can tie into your line, and you can cause a reaction or trigger a reaction on your line that will not allow production to run or trigger an alarm of some sort. You can do that, but that functionality is built in standard to all of our induction sealers. Conversely, the interlock circuit is available for all of our sealers, and that is if for some reason something happens on your line, you can trigger the induction sealer to shut off. So You can tie that into your line however you would like, but the functionality is there. Those two, the LSI and the interlock circuits, are often overlooked but could be extremely helpful to a lot of practitioners. The next one that we'll highlight here is the remote capabilities for the units. You can remotely start and stop these units, and you can remotely control the power control. So this is really applicable for the packagers that have some sort of line control system where they want to control everything through a PLC or through a computer elsewhere than the front of this induction sealer. The newer version of our systems, the SuperSeal Touch and the new SuperSeal Max, also has the ability to record some of these data options that Jeff was talking about within the touchscreen itself with using our recipe control functionality. So you can store the product name, you can store the output percentage and the alarm level that you want to run at, and then when you do run that product, you just call that up and your output's already set and adjusted to where you need it to be once you've defined that by setting up your operating window, as Jeff talked about. Next, we do offer a series of cap inspection options, and these are both mechanically and electrically integrated, as you see in this picture, with our induction sealer. So it's a real nice innovation that we've made with the cap inspection system. There are three main things that we're going to be looking at with the cap inspection system. The first one is going to be foil detection. So we're basically, with the cap inspection system, we're looking for probable causes. We're not actually physically inspecting the seal itself after the induction sealer, but we're looking for probable causes that will lead to a failure or will lead to a leaker. The first of those is the foil detection. As I mentioned, this is a real simple sensor just to make sure that there is a foil liner in your cap. It didn't fall out in your cap hopper or something along those lines. The second feature here is the cocked cap detection. This is just to make sure that you didn't cross-thread your cap as it went on your jar. If you did, or a grossly high cap is what we're looking for here. That would prevent us from getting good pressure, which would remove that from the equation, and you'd get a leaker. The next feature and the final feature for the cap inspection system is what we call stall bottle detection. So one of the last things you want when you're induction sealing is a bottle camped out underneath your induction sealer while your sealer's still running. That electromagnetic field isn't going to stop. So it's going to continue to heat up anything that's underneath of there. If you got a bottle stuck underneath of there, we want to be able to shut down that induction sealing unit so you don't burn. The stall bottle functionality will do that for you. The ejector that we offer two different styles of ejector. Both of them are piston style, as you see here. So it's the piston that's going to come out and kick your bottle off the line. There are two conditions in which our ejector will fire. The first would be if you're missing a foil. The second would be if your cap comes through and it's cocked or cross-threaded, and we pick that up with the cock cap sensor. Both of those will fire our ejector. You have an adjustable delay and an adjustable pulse length with our ejector, and it's a pretty simple mounting structure to your existing conveyor.
All right, thanks Owen and thanks Jeff. So let's take a quick review here before we get to our question and answer session. We covered the induction sealing absolutes: pressure, heat, and time. And Owen had pointed out that pressure is probably the #1 cause for failed seals, and so you really want to make sure that you've got the right torque. And when you get partial or no seals, that's one of the first places to look. Secondly, we covered all the different sealing head designs, and while you can try to seal different style caps, for example with a flat sealing head, they may not be optimized to do so. So it's always good, if you're running a new product, to consult with your cap sealer manufacturer to see what the specifications would be. We talked about determining a good seal and how there is no defined ASTM method for doing. However, there are a lot of different things that you can do, from vacuum testing. Owen cautioned on shaking, squeezing, and standing is good, but obviously it's not very consistent if you have different people doing it at different times. The operating window, again, probably the most important piece here. Again, following this best practice is going to help you increase your productivity and reduce your rejects. And lastly, the automation options. These are things that you can add. If you bought an induction sealer, we believe your expectation is that every container that leaves your facility will be sealed properly. So if you follow the best practices, add some of these automation features, you'll put yourself in the best position to achieve that. Again, available to you after the webinar, our induction cap sealing ebook, our new seal integrity guide, which will look at characteristics and remedies for partial, weak, and no seals, as well as overheated seals, and the setup log and checklist that Jeff referred to during the operating window setup. And again, one attendee today, we're happy to say, will win a Super Seal Junior. Again, we'll be letting them know this afternoon. With that, I'd like to move over to the question and answer session. And our panel will take a look here at the questions that you have submitted throughout the webinar, and please continue to use the tool to ask more questions. We have one question. What about spacing between bottles? How does that affect induction sealing?
Well, at Enercon, we have designed our power supplies so that they compensate for different amounts of bottles underneath the sealing head. We are continually monitoring the load that's presented to the coil and adjusting the power supply accordingly. Our goal is to keep the magnetic field strength constant, no matter whether there's 1 bottle or 10 bottles underneath that coil. We do that by monitoring the output, and as we need to pump more power into the coil to maintain that field, we will do that on a continuous basis. So the short answer to your question, I just gave you the long answer. The short answer is the spacing doesn't really matter when it comes to sealing. Now, it does matter when it comes to the cap inspection portions. If your bottles are back to back to back and there's no space in between them, our sensors will not be able to detect that there's a different bottle, and they will see the string of 10 bottles back to back as one big bottle. And they may detect that and think, well, there must be a bottle stuck in front of the sensor, so it will stop the unit as a stalled bottle kind of a thing. So that's the answer for spacing between bottles.
Do the set points change from day to day?
No. The quick and easy answer to that is no. What you'll find is that the setup that Jeff talked about is crucial. So that field strength is going to dissipate the farther away you are from the induction sealing head. So when you talk about pressure, heat, and time, we're always talking about changes to those variables that could affect the end result. So the sealer itself isn't going to change over time. It's not going to change from day to day. If you're running 65% today, you set your machine to 65% tomorrow, it's still going to be putting out 65% of its available power. But if you are running an 1/8 of an inch air gap today and a 3/16 air gap tomorrow, that could change, and that could change your end result. That's changing that heat in that equation. And that's what we find the majority of differences come from, is the setup side of things, and making sure that gap is consistent. That gap is absolutely critical, and just making sure your process is robust on the setup side to make sure that each day the induction sealer is set up exactly how it should be.
Thanks. So another question, what role does foil thickness play with induction sealing?
Well, the foil thickness does definitely come into play. What that does, if you change the foil thickness, you're essentially changing the mass of the foil that goes into the cap and it goes underneath the coil. The different mass of foil will require a different amount of power to get it up to the temperature it needs to be. On the other hand, if you have less mass, it's really interacting with the field less. So what we have found is that generally if you go to a thinner foil, which is pretty common these days, people are always trying to save a little money on their foil, thinner foil can actually take more power to seal, more output to seal, because there's not as much mass there, it's not interacting with the field as much, and it's not getting the energy. It's a less efficient way to transfer the energy into that foil.
Thanks, Jeff. Another question, do you detect conveyor speed?
That is a very good question. We get it quite often, obviously, the time. So what we're talking about is the time in that pressure, heat, and time equation. The conveyor speed is, we can detect it with some of our systems, our Super Seal Touch series and our new Super Seal Max. We can, with the cap inspection system option, we can detect the conveyor speed. But what that does, it doesn't change the output according to that conveyor speed. All it's there for really is a diagnostic or a setup assister. You could, as part of your protocol, you can go through and you can run a bottle through and verify that your time or your conveyor speed is set to where you need it according to the operating window that you set up. So it's a really good and helpful tool that's available on the Super Seal Touch and the new Super Seal Max. If you don't have those systems, a tachometer is your best friend. A digital tachometer is, I recommend them all the time. Anybody who's doing induction sealing should have one, because that time is critical. And if you have operators that go and adjust the conveyor speed from time to time, going back and periodically checking to verify that you're running within that window that you determined is a good practice.
What if you're running with 100% power?
I saw this one on the list and I wanted to touch on this one because, as Mark mentioned, the sealing window is one of the most important things that we're going to talk about today. And if you find that you're running at 100% power, or you need to run at 100% power, that's kind of a red flag to me. Generally, that means either your operator went and turned it up to 100% and didn't really give it a whole lot of thought, which happens all the time, or it means that you do not know where the maximum side of your sealing window is. You may find that you can get a good seal at 95, you run at 100, but you don't know. You might be right at the top end of your, or the bottom end of your sealing window for that matter. Maybe you can seal at 110% and still get a good seal. You might be right on the edge and not even realize it. If you're running at 100%, you really need to verify that you need to run at 100%, and you need to kind of go through that sealing window setup procedure to make sure that you know where the minimum and maximum are, to make sure that you're set up for success.
Is there a disadvantage to over-torquing caps?
There potentially could be. If you are jumping the threads, if you over-torque your caps, there's a aesthetics piece of this. If you're over-torquing your caps, there's a potential for scuffing those caps and disfiguring them with the capping quills or however you're doing that. But as long as you're not jumping the threads, and as long as the cap isn't warping, we see what we call saddling sometimes in the closures. If you screw them on too tight, one side will kind of pop up, that sort of thing. So you need to be aware of those things. But in general, the harder we can get those on, the better. But it's application by application basis.
What is the travel of the cap sealer up and down? Can it be easily moved 6 to 8 inches based on products that you might be running?
The quick answer is yes, it can be moved 6 or 8 inches up and down. We've got a couple of different mounts that you can use. To be honest, it kind of escapes me right now what the total maximum travel is. I think it's 15 inches that we can move up and down. But the mounts that we provide with our systems have hand cranks on them that will allow them to move up and down. If they're set up properly, you can easily adjust 6 to 8 inches for different kinds of containers.
Does the bottle need to be thrown away if the seal fails?
Does the bottle need to be thrown away? I'm going to try to read something into that question. And does that mean, should you try to reseal it? Generally, I would not recommend sending it through the sealer again, because you've already kind of messed up some things on that bottle and on that liner, and if you try to reseal it, it may not seal properly. So if that's what you're asking, I would say yes, the bottle should probably be thrown away if it does not seal properly.
Is there a certain amount of time you should wait after the caps are sealed to pull the cap off and check seals? This person has found that sometimes they aren't sealed right away, but if they wait 10 to 15 seconds, they will be.
That's a perfect question. We touched on this a little bit on the webinar, and yes, you need to wait until that induction seal is cool. Generally, cool to the touch would be what the liner folks are going to say. During the induction sealing process, we are melting that heat seal layer, and it came into a molten state. And immediately after the induction sealer, it's still in its molten state. So if you go ahead and remove that cap right away, you could destroy any seal that you created, and two, you're removing that pressure. And we want that pressure to be there until that seal had a chance to solidify, that heat seal layer firms back up and is more robust. So yes, I tell people wait as long as you can within your process to test. If that's 5 minutes, great. If it's 20 seconds, we should talk about it.
Are there any cap-jar combos that may require 2 sealing heads? Are there any advantages or disadvantages to running with 2 heads?
I can think of a couple cap-jar combos that would require 2 sealing heads. Now, they're not very common, and they're kind of unusual, but you've seen the fuel additives kind of things that you have to tip before you pour. They have a little, I'll call it a sidecar container, and sometimes their caps they actually have 2 caps on them, and they're at different levels. In that case, you're going to need 2 different coils to seal those. You'll need a deep tunnel for one and a standard tunnel for the other one. If you have an application like that, definitely give us a call, because those can be kind of specialized to make them work properly. But for a standard cap, I wouldn't really recommend. I can't think of another one that would need 2 different coils for a single cap.
Yes. As I'm reading that question, there are certain applications that will require 2 sealing heads. Certainly, if you have, for instance, a 28mm disc cap or a Yorker, and also are running these wider mouth jars, that sort of thing, it's definitely best to get 2 sealing heads. Could we do it with 1? Potentially, but you get a much more efficient sealing process if you use the correct sealing head for that specific jar or cap combination. So there are drawbacks. The changeover with the sealing heads these days is extremely simple. It's 4 bolts, and they pop right out. You can change over a sealing head in a matter of a couple minutes. So,
are some materials, certain types of plastics, for example, not compatible with foil induction sealing?
Well, there are definitely, you need to make sure that your foil liner, the sealant layer on your liner, is compatible with your bottle. If you have a liner that's designed for PET and try to use it on the PE bottle, there's no guarantees that that liner is going to stick properly. So in that instance, there are limitations. There's also some limitations when it comes to sealing to glass. If you have a glass application, give us a call. We'd like to talk to you about it, because glass can be tricky, and the liner guys will tell you the same thing.
Jeff, we addressed this one earlier, but it keeps popping up, so I want to make sure that everyone hears the answer. This question is formatted as, does loading underneath the sealer matter? Example, 1 jar, 2 jars, 3 jars.
Does it matter? It does matter. You need to. If you're overloading your system, you need to know that. But that's what the stack light is for. That's what the LSI contacts are for. If your unit overloads, it will tell you if you're paying attention. But generally, we have designed these systems so that they will not overload. 1 container will seal at the same speed with the same output as 3 containers, 4 containers. And one of the things we've done is over the years, when I first started here, our coils were 3 feet long. Now our coils are about 10 to 15 inches long, and there's not as much room to fit so many bottles underneath there. So loading has become less and less of an issue.
Can you explain the difference between PET and HDPE bottle seals?
Yes, to some extent. So we are We are obviously familiar with all the liners and the liner manufacturers. There's several out there that would be very knowledgeable, and we can pose this question with them as well. But in general, the induction sealing, as Jeff mentioned, you have to have a liner that's compatible with your bottle material to get that to stick. So there are liners out there that are dedicated to HDPE. There are liners out there that are dedicated to PET bottles. Depending on your peel strength and your characteristics that you're looking for, there's weld bond liners, there's clean peel liners, that sort of thing. And what we want to do is make sure that that liner is compatible with your bottle material. The only difference could be that the heat seal layer, instead of being mostly PET, if it's designed to stick to a PET bottle, the heat seal layer might be made up of mostly HDPE. And depending on the peel characteristics, they might dilute that layer with some other materials. The liner folks would be able to tell us that, but basically it's just a matter of that heat seal layer and what it's made up of.
Any words of wisdom for creating a peelable seal, finding the narrow sweet spot between a reliable seal and an easy to peel seal?
Well, Owen kind of just touched on this actually. The words of wisdom would be get the right kind of liner. There are different kinds of liners that are designed to create a good seal yet still be peelable. There are other kinds of liners that are designed to, when they have a good seal, you have to cut them to get them off. Those are welded bond liners. If you're trying to get a peelable seal with a weld bond liner, it's going to be a losing battle. You're going to get leakers because you're going to be running on the very low end of your operating window. And I would definitely recommend getting a peelable liner, and all your problems should go away.
We had a question before about thinner seals. Is a thinner foil suspect to more hot and cold spots?
This again depends on the application. The thinner foils, generally speaking, you could find yourself with a more narrow processing window with the foil seal. It's going to heat up really fast. It's going to cool down really fast. The only time that we've gotten ourselves into some trouble with the thinner foils is when you talk about tabs, and this is really going into a whole different conversation. But when you deal with tabs and thinner foils, you could see hot spots where there are no tabs, but not getting as adequate of a seal where there are tabs. It depends on the diameter, it depends on the foil thickness, depends on the liner itself. So if you're seeing issues like that, by all means, give us a call. We're happy to run some samples for you, free of charge, and we can take a look at it for you.
Should we be worried about low torque post sealing with foam liners? Low torque equals approximately 10 pounds.
Well, one thing to keep in mind when you seal something, what we're doing is we've got pressure on this liner, then we're heating it up, and the lowermost layer of this liner is it's essentially a plastic that's compatible with your bottle, and we are melting that and pressing it into with the pressure of the cap, we're pressing it into the bottle. Some of that material of that layer of the liner is going to be squeezed out. So whether you've got a foam liner or a paperboard backer or whatever kind of liner you've got, you definitely should expect lower torques after you seal than the application torque that you put on. It's just kind of a rule. You've essentially squeezed some of the material out of there, and you haven't tightened the cap up at all. So there's going to be less torque after you seal than there was before you sealed.
Do the handheld units need annual testing to ensure consistency?
Do they need annual testing? It depends on your application, really, your stance. You know, some of our customers run these things for years without any other ones, any validation or anything like that. Other customers, they have processes set up that they need to get their things validated or calibrated every year. We do have a program where you can send your Super Seal Junior in once a year, and we will calibrate it for you. It's not something we recommend doing in the field. You have to have the right test equipment for it. But if you're interested in that, you can give us a call, and we can help you out with that.
How can we validate the induction sealing process?
This is we get this question quite frequently as well. We do sell with our production systems. We can sell a validation package. That's a complete IQ, OQ, PQ that we can sell. Otherwise, you can validate them yourself. Basically, what you will need to do is put the sealer through its paces, and this goes back to a lot of what Jeff was talking about with the recording of the data and the settings and everything, and in verifying your setup and making sure that is all tight for your application and for your process so that you can really validate what you're doing and how that's going to affect your induction seals.
A couple of questions about retorquing. Is it necessary to retorque after sealing? And the second question is pretty much the same.
Is it necessary? It depends on the application, depends on the industry. So if your industry is such that it mandates certain removal torques fall within those specs, and you are using a liner or your application, you do lose some of that torque when you're induction sealing, then yes, retorquing may be needed. For most folks, retorquing isn't necessarily needed. It's once you seal your bottle, the induction seal's there, your bottle's sealed. It's more of a consumer kind of a cosmetic aesthetics thing with your customer to make sure that that cap is on tight. It's up to you whether or not you really want it. But if we find that two-piece liners typically, if you have a layer of wax and a pulpboard in your cap, you will lose some of that application torque, and your cap may seem a little loose after the induction sealing process. It's a result of that wax layer melting and absorbing into that pulpboard. So those would be the applications where retorquing is probably more popular.
What is the minimum cap diameter that can be accommodated by the flat sealer, the new model, referring to the all-in-one sealing head? What is the minimum cap diameter that can be sealed?
Well, the all-in-one, the universal one, can seal down to about 20 to 24 millimeters. Below that, I would recommend a tunnel coil. We also have, I saw in the question, it said the flat coils. I don't know if we had a picture of a flat coil. We did have a picture of the flat coil. Though the flat coil that is not a universal head, that is designed specifically for larger heads, that can go down to, I wouldn't use it much smaller than 53 millimeters. The efficiency really drops off at the smaller speeds or smaller sizes. And part of the question was, will the universal coil eventually replace the tunnel coil? And the answer to that is, I doubt it. Like I said, it's a jack of all trades, but it can't quite match the performance of a tunnel coil if you've got a dedicated line. If you're a co-packer or something like that that is always running different kinds of caps, different sizes of caps, it's perfect for you. If you're a pharma company that is always running the same bottle on this line and you never have to change it, the most efficient way to get the heat into that foil is with a tunnel coil.
What's the best cleaning method? This customer blows out the coil with an air hose. Is that beneficial?
The cleaning method for our units is definitely blowing it out with an air hose. There's not a lot of parts now that we don't make water-cooled systems anymore. They're all air-cooled. There's nothing to worry about getting into the sealer power supply itself. What we've got that needs cleaning outside basically is the fans that are underneath the system. One of them blows to the bottom base plate of the sealer. One of them blows into the coil. So we want to make sure those fans are clean and functioning. And sometimes you need to clean out the coil. The coil needs airflow through it to stay cool. And there are vent holes, we'll call them, and if those get plugged up with dust and product and things like that, it's going to decrease the cooling ability that we've got on that coil. So those need to stay clean so that you can keep the cooling going.
To piggyback on that question real quick is what I would not recommend doing is customers will be tempted to try to take apart the sealing head to clean it out. These sealing heads are designed to stay put together, and I would not recommend trying to take them apart. The screws that we hold in are all nylon, and during the manufacturing process, things are pretty well stuck in place, so you can damage the head by taking it apart. Definitely recommend using an air hose as opposed to taking it apart.
You mentioned the need for a tunnel unit if there is a large amount of headspace inherent to the cap. How much headspace would trigger moving to a tunnel unit?
It seems like every question we say, well, it depends on your application, but it does kind of depend on your application, how fast you want to go. Keep in mind that as you move the foil further and further away from the coil, the efficiency goes down and down. You can take one of our standard narrow tunnel coils and run a disc cap that's got maybe a 3/8 inch gap built into it. If you don't need to run too fast, that's fine. If you need to run faster, as you get more than, say, I would say a 1/4 inch gap that's built into your cap, you might need to start thinking about a deep tunnel coil that instead of generating the field from the sides and the top, it just generates the field from the side. Obviously, a sports cap like or a syrup cap or a Yorker cap, those are prime candidates for a deep tunnel coil. But the disc caps, the flip top caps, they're starting to approach that as well.
We have a customer using a Super Seal 100 and is asking if there are any upgrades.
There certainly are, depending on what you ordered that originally with. Our standard Super Seal series, so you'll hear our Super Seal 50, our Super Seal 75, and our Super Seal 100. The only options that aren't necessarily available for that are the full stall bottle detection and the cocked cap detection. You can certainly do foil detection. You can add an ejector to that. The LSI functionality is built into that system. The interlocks is built into that system. So you can utilize all those features that we have in there already, and you can add on foil, and you can add on what we call bottle backup detection, which is a sensor downstream, which will pick up downstream backups before they get to your induction sealer. So there are some possibilities to upgrade that. Otherwise, the Super Seal Touch series that we highlighted before would be kind of a replacement system. It uses the same sealing heads, but it just has some additional features that you can add on, mainly the cap inspection system and some of that functionality.
All right, looks like we're pushing up against our 1 hour here. We've got time for one more question. In a production setting, the speed of the machine is important in the efficiency of the line. Ideally, is there a preference as to how the induction unit should be used, high energy or low energy?
For our induction cap sealer, it really, it does not matter whether or not you're running it at 100% or running it at 50%. What that's essentially doing, we're using a certain amount of its power. As Jeff touched on earlier, if you're running it at 100%, it's not going to hurt your unit a bit, but it just limits your operating window potentially. So yes, going back to the question, there's no benefit to running it at a lower output percentage. The only time that we should look at that is if you're having wax melt issues with the two-piece liner or something like that, then we can talk about it. But in general, you can run that wherever you want, as long as the induction sealer should never be a limiting factor on your production line. I always say that. So it's better to err on the side of too much power as opposed to in running that at a lower output percentage than you.
All right, some great questions. Want to thank you for your time today. We hope you found this informative. As you can tell, Jeff and Owen have a deep knowledge and understanding of both equipment and applications. So if you do have more questions, please reach out to them. We'll be sending you an email out within the next 12 to 24 hours, which will have all the information that we promised you, including the additional handouts. If you have an idea for a webinar in the future, please let us know that as well. Thank you again, and this will conclude the webinar.